In this video, we are going to work through 3 practice problems in physics that involve inelastic collisions in one dimension. Now, it's important to know that an inelastic collision between two objects, when that occurs, the momentum is conserved, but the kinetic energy is not conserved. So let's keep that in mind when we're working through these problems. So let's check out this first problem. It says, a 10-gram bullet is fired into a 5-kilogram block of wood. The bullet gets lodged into the wood, and the speed of the bullet plus wood combination is 0.6 meters per second immediately after the collision. Find the original speed of the bullet. So let's sketch this out. We have this bullet that's traveling towards this block of wood that is 5 kilograms. And the bullet will get lodged into the wood. So the bullet will be lodged inside of the wood. And when that occurs, this combination of the bullet and the wood is then traveling at a velocity of 0.6 meters per second. And our question is, if that's the case, what was this initial velocity of the bullet? So in order to solve this problem, one thing we have to understand is that in any type of collision between two objects, whether it's inelastic or elastic, the momentum is always going to be conserved. So what we can say is that the initial momentum, and momentum is denoted with a lowercase p, it must be equal to the final momentum. Now, momentum is calculated as mass times velocity. So the initial momentum in this example is going to be the mass of the first object, which is the bullet, times the velocity of the first object, plus the mass of the second object, which is the wood, times the velocity, the initial velocity of the wood. And that's going to be equal to, for the final momentum, we're going to have the mass of the first object times the final velocity of the first object, plus the mass of the second object times the final velocity of the second object. Now, in this example, we said that the bullet is lodged into the wood. So the final velocity of both the bullet and the wood is going to be the same since they're attached to each other. So instead of writing v1 final and v2 final, we can just say v sub f, the final velocity, since it will be the same value. So let's write that. We'll say v sub f plus m2 times v sub f. And lastly, to simplify this a little bit, we can factor out the final velocity on the right-hand side. So here's what we get. m1 v1 plus m2 v2 is equal to, we'll factor out this final velocity, and we have m1 plus m2. Now, in this equation right here, we're trying to solve for v1, which is the original speed of the bullet. So let's go ahead and fill in all the values we know and we'll solve for v1. So m1, that's the mass of the bullet, that's 10 grams. We want to convert this to kilograms, so we need to divide that by 1,000. So that will be 0.01 kilograms times v1, we don't know what that is yet, plus for v2, this is the velocity, the initial velocity of the wood, and the block of wood is at rest. So actually this entire quantity is just 0. So that's it for the left-hand side. On the right-hand side, we have the final velocity, which we're told is 0.6 meters per second. And we're multiplying that by m1, the mass of the bullet, so 0.01 kilograms, plus m2, the mass of the block of wood, that's 5 kilograms. So we get 0.01 v1 is equal to, on this right-hand side, this turns out to be 3.006. And to solve for v1, we'll just divide both sides by 0.01. What we end up with is v1 is equal to 3.006 divided by 0.01. That comes out to 300.6. And we're talking about velocity, so we'll say meters per second. So that's our final answer on that one. That is the original speed of the bullet. All right, let's check out this second example. It says an 85 kilogram receiver is running 6 meters per second to the right and catches a 0.43 kilogram football traveling at 30 meters per second to the right. Find the speed of the receiver holding the ball immediately after making the catch. So let's sketch this out. We have this receiver that's running to the right at 6 meters per second. And he catches a football. So let's say he catches the ball. Here's our football. And the football is moving at 30 meters per second. And our question is, what is this final velocity going to be of this receiver holding the football? What is this final velocity going to be? So once again, we have a collision in which a ball is colliding with the receiver and then they're sticking together. So they're staying together and they're continuing to the right. So again, in any type of collision, momentum is always conserved. So once again, we can say the initial momentum must be equal to the final momentum after the collision. So for the initial momentum, let's see what we get. We have m1, the mass of the receiver, times v1, the velocity of the receiver, plus m2, the mass of the football, times v2, the initial velocity of the football. That must be equal to, remember the equation we used from the previous example. We have the final velocity times the first mass plus the second mass. And in this scenario, we're trying to solve for this final velocity right here. So let's go ahead and fill in all the values we know. m1, the mass of the receiver, that's 85 kilograms, times the velocity of the receiver is 6 meters per second, plus m2, the mass of the football, that's 0.43 kilograms, times the initial velocity of the football, which is 30 meters per second. That must be equal to the final velocity times the mass of the receiver, 85 kilograms, plus the mass of the football, 0.43 kilograms. So let's go ahead and solve for this final velocity. So if we simplify a little bit, on this left-hand side we get 510 plus 12.9 is equal to, on the right-hand side we end up with 85.43 times the final velocity. So on this left-hand side we end up with 522.9. On the right-hand side, we have 85.43 times the final velocity. To solve for the final velocity, we'll just divide both sides by 85.43. And our final answer, the final velocity, ends up being 522.9 divided by 85.43. That comes out to about 6.12. And we're talking about velocity, so we'll say meters per second. So this is the final velocity of the receiver holding the ball. And this should make sense because if we notice, the receiver was initially running at 6 meters per second. So when they catch a ball that's moving in the exact same direction as them, that should speed up their final velocity by a little bit. And we see that it does. So it's 6.12 meters per second, which is slightly more than the initial velocity of the receiver. So that's our answer for that one. All right, let's check out this very last example. It says a 3,000 kilogram truck traveling at 15 meters per second strikes a stationary 1,000 kilogram car, locking the two vehicles together. This is a two-part question. Part A says, what is the final velocity of the two vehicles? And part B says, how much of the initial kinetic energy is lost to the collision? So let's start with part A. So let's go ahead and sketch this out. We have this truck that is 3,000 kilograms traveling along at 15 meters per second. And it collides with this car. Here's our car. That is 1,000 kilograms. And the two end up being locked together. So we'll say they are locked together, something like this. And we want to know, what is this final velocity going to be when these two are locked together? So once again, we have a collision, and we know in any collision, momentum is going to be conserved. So we know that the initial momentum must be equal to the final momentum after the collision. So the initial momentum, that's going to be the mass of the first object times the velocity of the first object, plus the mass of the second object times the initial velocity of that second object. And that must be equal to the same equation we've used in the previous examples, the final velocity times the mass of the first object plus the mass of the second object. So let's go ahead and fill in the values we know, and we'll solve for this final velocity. So m1, the mass of the truck, is 3,000 kilograms. And its initial velocity is 15 meters per second. Plus, for the car, it's initially at rest, or it's stationary. So this value for velocity is 0. So this whole quantity is 0. So we end up with is equal to the final velocity times the mass of the truck, which is 3,000, plus the mass of the car, which is 1,000 kilograms. So if we solve for v sub f, let's see what we get. On this left-hand side, we end up with 45,000 is equal to, we end up with 4,000 times the final velocity. To solve for final velocity, we'll divide both sides by 4,000. And we'll find that the final velocity, let's write that on the left-hand side, that's equal to 45,000 divided by 4,000. That comes out to 11.25. And we're talking about velocity, so we'll say meters per second. So this is our answer for part A. So that's the final velocity of the two cars when they're locked together. Part B wants to know how much of the initial kinetic energy is lost to the collision. So first let's find what is the initial kinetic energy. We'll say kinetic energy initial. That's going to be equal to, the formula for kinetic energy is 1/2 times m, the mass of the first object, times v1, the velocity of the first object, squared. And to that we have to add the kinetic energy of the car, which is 1/2 m2 times v2 squared. Now, we said that v2, the car is initially at rest, so this whole quantity is actually just 0. So the initial kinetic energy is going to be 1/2 times m1, the mass of the truck, which is 3,000, times the initial velocity of the truck, which is 15 meters per second, squared. And if you punch this quantity into a calculator, it comes out to 337,500. And we're talking about energy, so our units will be joules. So this is our initial kinetic energy. Now let's find what is our final kinetic energy. So we'll say kinetic energy final. And that's simply going to be 1/2 times m1 plus m2, because the two objects are stuck together, they're locked together, times the final velocity squared. So we just found the final velocity is 11.25, so what we'll end up with is 1/2 times m1 plus m2, their total mass is 3,000 plus 1,000, which is 4,000. And then we're multiplying that by the final velocity squared. So if you punch this into a calculator, this comes out to 253,125, and that will be joules. So here's the initial kinetic energy, and here's the final kinetic energy. So the total kinetic energy lost is going to be the difference between these two. So our final answer is going to be, for part B, if you do 337,500 minus 253,125, that comes out to 84,375, and we'll say joules. So that's how much of the initial kinetic energy is lost to the collision. So those will be our answers for part A and for part B.